JEE Advanced 2025, Paper 2, Physics, Question 4. Let us first visualize the system. We have a heavier star of mass m1 and a lighter star of mass m2 revolving around it in a circular orbit. Mass is being transferred from the lighter star to the heavier one. Let me keep this diagram in the corner for reference as we go through the problem. Here is the question. Consider a star of mass m2 revolving in a circular orbit around another star of mass m1, where m1 is much greater than m2. The heavier star slowly acquires mass from the lighter star at a constant rate of gamma kilograms per second, with no other loss of mass. If the separation is r, find the relative rate of change, that is, 1 over r times dr dt. The key concept here is conservation of angular momentum. When mass is transferred radially between the two stars, there is no external torque on the system. So the orbital angular momentum of the lighter star around the heavier star is conserved. We also use the fact that for a circular orbit under gravity, the orbital velocity depends on the central mass and the orbital radius through Kepler's laws. Let us solve this step by step. For the lighter star of mass m2 in a circular orbit, the orbital velocity is v equals the square root of gm1 over r. So the angular momentum is L equals m2 times v times r, which gives us L equals m2 times square root of gm1 r. Since mass is transferred radially, there is no external torque. Angular momentum is conserved, meaning dl dt equals 0. Differentiating L equals m2 times square root of gm1 r with respect to time, and noting that dm to dt equals negative gamma since m2 is losing mass. Applying the product rule to differentiate m2 times square root of gm1 r. Since m1 is much greater than m2, the change in m1 is negligible compared to m1 itself. So we treat m1 as approximately constant. This simplifies our differentiation significantly. Substituting dm to dt equals negative gamma and simplifying. We get negative gamma times square root of gm1 r plus m2 times square root of gm1 over to square root of r times dr dt equals 0. Solving for dr dt, we find dr dt equals to gamma r over m2. Therefore, 1 over r times dr dt equals positive to gamma over m2. Now here is the interesting part. Our calculation gives a positive value, plus to gamma over m2, meaning the orbit expands as m2 loses mass. This makes physical sense because as m2 becomes lighter, gravitational pull weakens and the orbit widens. However, all 4 options in the paper have a negative sign. This means none of the given options match the correct derivation. This is why the exam board decided to award marks to all candidates for this question. The official answer for this question is marks to all. The JEE Advanced 2025 committee awarded full marks to every candidate who attempted this question, acknowledging the discrepancy in the options. The closest intended answer was option B, negative to gamma over m2, but the sign is incorrect based on the standard derivation. Here are some important tips for JEE Advanced. First, in variable mass orbital problems, always identify what is conserved. Angular momentum is conserved when the force or mass transfer is purely radial. Second, Kepler's third law connects orbital period, radius, and central mass. For circular orbits, v equals square root of gm over r. Third, always check the sign of your answer physically. If the orbiting body loses mass, the orbit should expand, giving a positive dr dt. Fourth, if your answer does not match any option, verify your approach and consider that the question itself might have an error. In exams, flag such questions and move on. If you found this helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.